Okay. Been practicing my flap sweat all day, so I'm ready, I'm prepared. Okay, so RxJS subjects in Angular projects. Real quick, a little bit about me. I have a bachelor's in computer engineering from Purdue, alumni of '09. Got about a decade of experience in independent verification and validation, so breaking other people's stuff, which they're usually not very happy about. Several years as a full stack developer, started with LAMP, so Linux, Apache, MySQL, and PHP. Recently picked up Angular when it was Angular 4 and Spring as well. Fun facts, I paint things and I travel all over the place. And there's my Twitter handle. You can see all of my not programming stuff. So here's an overview of what I want to cover today. We'll quickly first talk about the observer-observable pattern. That's our main mechanism for handling asynchronous things, event-driven tasks. We'll then dive into RxJS subjects and their various derivatives, the BehaviorSubject, ReplaySubject, and Async Subjects. Briefly touch on testing considerations when you're using these devices. Then we'll look at some code, and then there's Q&A and discussion if there's time. And I thought I meant to take that last one off. Sorry about that. So, observable patterns. Observables, they source events, and they have knowledge of subscribers. Anybody out there used HTTP client with Angular? Yeah, so we know that that fires off the API call as soon as the first subscriber subscribes, right? So obviously we know that observables can tell when things subscribe to them, so they know they're being watched. Examples of observables in Angular, you have output bindings. Anytime you're using those nice parentheses on things, an output bind from your HTML into your component, that's effectively a observable. Anything that's an event emitter, our HTTP client methods, get, post, put, etc. If you're using reactive forms, then whenever you listen to value changes or status changes, you're subscribing to it, that's an observable. Subjects, of course, the subject of the talk. You can cast promises to observables, and you can also just make anything an observable, though that tends to not work the way you think it does. Observers, these are things that do the watching, listening, and reacting. So these consume events get fired into them. They can choose to react to them or not based on whatever code you might happen to put into them. In the case of something like an output binding, we can use the $event to grab whatever might come out of that and act as input into whatever our function is that's taking that event. Yeah, whatever code you might happen to write. Since we're looking at subscriptions here, it's interesting to note that there's 3 different functions that actually happen inside of those. We'll touch on those later. But besides the normal success case of when I actually got data back and I'm going to do something with it, there's also the error case, which is really useful to know about, especially if you don't want to spam your console with uncaught errors. And then there's the close, which is also interesting. And then, of course, subjects themselves are observers. So quickly, if we look at the subscription lifecycle, this is the most advanced I've written to subscribe. I've not yet done anything that involves a complete, but it's interesting to note that the subscribe has multiple paths when the event gets thrown. If the event was a successful event of some sort, then the observable calls the next function on the observer, and that is our success path, which the docs note as observer or next, but we can call it whatever we want, typically bringing in that input and passing it off to some sort of function. There's the error path for anything that happens to go wrong. Interesting thing about that is for all of our observables, if an error gets thrown, it also shuts down and it will not emit any further events. So one pattern to think about is if there is an error and you want it to be not catastrophic, then you'll have to reconstruct your observable pattern. And then lastly, there's the complete, which is useful when the subscription completes but not as part of an error. So if there's something like an HTTP call and that API completes and it's going to shut down, it will call the complete and then that subscription is torn down. If you want to inject some custom code in there, maybe you want to catch a WebSocket closing unexpectedly, but it's not an error, it just drops. Maybe you want to have some sort of code that tries to reestablish the WebSocket. Or maybe you want to notify the user that something closed, but it wasn't an error. Maybe they just to confirm they closed something.
Let's put this on just in case.
Sure. Okay, so we look at subjects, and the interesting thing here is that they're both observers and observables. They can watch and they can be watched. You can inject them into a subscription, and the cool thing is you can just call subscribe and then feed in the variable name of the observer. It knows how to hook into one automatically. They consume events. They emit those same events to all observers, and they're typed. So we need to know when we're using them what kind of data we might be using with it. So we need an interface here or a object, or you could throw any in there, but then you're kind of shooting from the hip, Wild West style, and good for you if you're doing that. But the real question is, why not just subscribe to the original source, right? If we already have something that's emitting events, why not just subscribe to that? Why put an intermediary in there? Anybody have an idea? The answers are on the page. Decouple. Decouple's a good one. What was the other one I heard over here? No? Okay. Yeah. One great reason is scope. If I have an event coming from inside a component being driven off the HTML DOM, and I need to broadcast that event up to a parent component, my parent can't get into the child to subscribe on that, unless I do something nasty like a view child, which just very tightly couples those things, and that's a real pain if I have an array of them or any other kind of moderately complex thing. So if we're trying to get around scope, it's useful because we can put our subject in the middle layer, and I have examples of this. And then we can basically broadcast that up the chain cleanly. It's also interesting that observables and subjects will help you with multicast. So like we talked about at the beginning, http.get or post or put fires as soon as that first subscriber comes in. So what you could do if you wanted multiple people to get that is you could have everybody subscribe to a subject, then have, when you're ready, have the subject subscribe, and now when the HTTP client get fires and responds, it hits the subject and goes out to everybody instead of just the first person who happens to grab onto it. So if you're doing any kind of multicast, subjects are pretty useful. Behavior subjects are an extension of a subject, and if you look at the source code, it literally extends subjects. And what it does is it adds a cache, which is cool. Behavior subjects offer synchronous data viewing of whatever's currently in the cache. So if you need a cheap way to convert from asynchronous to synchronous, check out a behavior subject. It's cool. You can get the value as a property or as a callable. So if you have some reason you need to use a callable, you need to pass it off to a function. Hey, when you need data, call this to get it. You can do that. The downside is they must be initialized. Because they're a cache, they have to have something in them. They can't be empty. A lot of times that's a null or an empty object or something like that, which can be a problem if the rest of your code that interfaces with the data stored in the cache isn't null safe. We'll see that come up as a testing concern. So behavior subjects are useful as a cache. You can also use them as a state register in state machines. Computer engineer, so I'm part hardware, part software. Anybody out here know about state machines? All that kind of cool stuff? Yeah. So you can use a behavior subject as a register. So you can basically have the type of the behavior subject as your state enumeration. And then you can send next. And then anybody who needs to watch your state and watch it change or respond accordingly can then get updates every time there's a state change. You don't have to write any code for it. You just subscribe to the behavior subject, and now anybody can check the state whenever they want to, or get updates on whenever the state changes. That's really useful for setting up, I can never remember if it's More Machine or the other one, but you can then set up your various flags as functions of the state, and they just change whenever the state in the cache changes. So getting into the more weird ones, more difficult to use, a replay subject is a buffer, where the other one was a cache, and it was stateful and held onto the data and let you access it whenever you wanted to. The replay subject is a buffer, and basically it just queues things up and fires them off as they're received or whenever somebody new subscribes to it. You can turn on a buffer expiration time. So if for whatever reason you need the data to expire in a certain amount of time so that another part of your system goes and refreshes it, or it's just maybe a temporary push notification or something like that, you can set that up. And lastly, it takes a scheduler which is apparently a way for you to configure the replay subject to emit the things in the buffer on some sort of schedule. I haven't played with that, so I can't really speak to it, but it's there. It's in the source code. It does something. It's there for a reason. So the interesting thing about a replay subject, it replays the entire buffer, however big you make it, whenever a new thing comes on. So if you have some lazy loaded part of your application that needs to get a series of events that the user made, maybe it's maybe you're storing chat messages as a queue of events. Maybe you want to be able to do undos, so you're capturing the last 5 or 10 user actions as events in something, but they expire for some reason. You can also make it not expire. So if you just want a rolling buffer of 5 or 10 or whatever, you can just not expire it. So if a new subscriber comes on and the buffer has something in it, then it's going to just zip and run through all of those and play them back out to the new subscriber. And it does this individually for new subscribers. So if I have somebody already subscribed and it's already caught the 3 events in the buffer and a new one comes on, it doesn't replay for everybody, it just replays for the new subscriber. So it gets that new person caught back up. So it's useful as a buffer, and if anybody has used ShareReplay as a way to effectively debounce or protect an HTTP call from firing and hammering a backend multiple times, ShareReplay actually just wraps a replay subject. So that's kind of interesting. And then lastly, Async Subjects, and we'll touch on this just for a minute. It's also a buffer, it's size 1. It doesn't emit any events when they're observed, so it just throws everything away except the last thing it saw, and then it fires those events to all listeners when the thing it's watching completes. Yeah, it's kind of weird. I was curious, so I searched all of GitHub for anybody using an async subject. Only 17 files had one. Out of the entirety of public GitHub, only 17. Of those, 5 were exports, and that's RxJS crew exporting this to various libraries. 2 of them were spec files, so they're using an async subject for some reason, probably as a way to, who knows what. 3 of them were readmes, talking about the project. Probably 3 of the readmes were about the 7 academic studies of subjects. These were files that imported all 4 of these, the subject, the behavior subject, the async, and the replay. Probably somebody doing some sort of test thing. So if you can find a use for one of these, please let me know. I have no idea what it's there for, but somebody thought it was cool and built it and published it, and there it is. So it's a great thing about software, right? Anybody can do it. Testing considerations. So for all of the subjects, subscribe before you push events, otherwise you'll miss those events. If your watcher isn't there on the subject and you start firing test events into it, they just go into the ether, unless it's a replay subject. Behavior subjects, because they're initialized, they're a cache. If you start writing tests assuming it's initialized, well, remember, the test bed doesn't do anything without your explicit command, so it's not going to initialize anything. It'll run something in the constructor, but it won't run anything in on init. So initialization of behavior subjects should either be on the property or in the constructor, not on ng on init, unless you want to manually fire your detect changes and force it to update. And the main thing there is, if you don't handle this correctly, what happens if your system gets that dummy initial data? What happens if it gets a null, or an undefined, or a dummy empty object with a whole bunch of nulls and not a numbers and whatever you've initialized your empty POJO to be? On the flip side, that's also a really good test. What happens if I throw just a whole bunch of empty blank CRUD at my system? How does it handle that? Is it null safe? Does it safely do those things? For replay subjects, if you're using one, definitely play with its feature about subscribing after the events have been pushed into it. Because what happens if you get all the events at once instead of every second as you're expecting them to? If whatever process that responds to those events takes some time, maybe it's storing into a database, maybe it's doing some other asynchronous task. What happens if you get all 3 of them and now you've got a backup? How does your system handle that? That's kind of interesting. And if you're writing tests about an async subject, again, I'm curious why. Because I don't know what it does. So a quick review of the subjects. The main primary subject is just a pass-through. It doesn't store anything, doesn't keep anything, it just emits whatever it sees. The behavior subject is a synchronous cache. I can load data into it, and I don't have to subscribe to it to see it. I can call .getValue, and I can see it instantly which is kind of cool. It gives me an exit out of asynchronous things. The replay subject is a buffer, configurable size, optional expiration. So if you want to only fire an API call once ever, then throw the data into a replay subject and expose the replay subject as the subscribable, and never worry about hammering a backend again. They'll have to refresh the page to hit the backend. And then the async subject, who knows? So let's get to the code already, yeah? For those interested, repos for the code I'm going to show you are here. I assume we can fire the PowerPoint out afterwards?
Yeah.
Okay. If anybody wants to scribble that down, I can always put the slide up at the end. Okay. So let's do that. Let's jump to here. And let's make that noticeably more readable. Can everybody read that okay?
Yes.
Okay. Okay. So going back to the beginning, observe our observable patterns. We see the word subscribe in here a lot. Everybody's familiar with subscribe for the most part? Hands, nods? Okay. So subscribe is our main mechanism for handling anything asynchronous that's going through an observable. Because we're not talking about promises. Promises are a bad word here. And there's some interesting things going on here. But to put this code in context, let me show you what the app does. So this is a very basic employee database. Woohoo, it's a dental app. It's boring as hell, but here we go. So I can enter names. If I enter in an address, the system will eventually fire an API call and run address validation and show me some corrected addresses, which is kind of cool. If I pick one of these, oh yeah, I'm North Rosedale. Okay, so it updates my address, and then I can submit, and I see my API fire call. The first one is a what can I do? The second one is a post. So if I look at this, I can see my posts. I now have a new ID. The ID is 10,112. Cool. I can go to a list. I can see all the people. In my fictional scenario, these are all people who are at a hotel for a convention. Not too dissimilar from this. So these are people. I may want to look them up by their first name. So I can change my sort by toggle here to check that. Sort direction is not working for some reason, although it's firing API calls. I still haven't figured that one out. And I can also change my record size. So if you watch the scroll down bar, you'll see it jump from 10 to 25. And sure enough, I've got a whole bunch of stuff. Check out John Hammond. He's in the penthouse. Good for him. Well, spare no expense. I can jump to page 2. If I jump back to a smaller record size, my page numbers update with all of my different stuff. So kind of a cool just demo of a paging and sorting type list, which is a fairly common way of showing a list of data. So what's happening under the hood? This is my address form component. So this guy is responsible for just the address part of this form. So all the address validation stuff happens inside this guy. So what are we looking at here? So this first one is listening to value changes. If we remember back when we were talking about things that you can observe, if you're using reactive forms, value changes is a thing you can do. So I have a form group that's built in here. Let's see, it's passed down from the parent is where it is. But what I can do is I can listen to value changes on the whole group. So if anything happens inside any of the child fields, value changes fires. So this first subscription calls this handle address change function, which converts the address from the JSON I get from the reactive form into my nice, pretty Pojo. And the address change handler does some magic. The second one here, we notice a debounce time and a pipe. So this is the piece that eventually fires off address validation after 2 seconds. Anybody familiar with pipe and debounce time?
Is this RxJS 6?
Yes, this is 6. This is also Angular 6. So we can see it's, yeah, it's RxJS 6. All right, so debounce time basically says we're going to queue up events until eventually the timer runs out, and then eventually we'll let the event go through, but only the latest one. Who wants to hazard a guess as to what type of subject is in there? Sounds a lot like a replay subject, right? It's going to queue up a whole bunch of things and then only fire one of them, right? And then the last piece here is a shared service. So that's hooking into a behavior subject that stores whatever results I get back from Smarty Streets, which is the address validation service, and then handles the success case or my error case. If we look at the HTML, we can see I have a child component here, which is my address suggestions. So that handled those little cards on the bottom that displayed the different suggestions and had the select buttons, right? So I have an output binding here. So looking at this, I know that there's some sort of event emission coming out that's named address selected. I'm tying that into my set address function and capturing whatever event data happens to come out of that and throwing it into the set address function. And if we look back at the guy that handles that, set address grabs the form group, stuffs the address in there, clears any errors that might be on it, clears the cache in the validation service, and then sets my state machine to valid. Now there's a state machine going on in here. State machine is here. This is a behavior subject acting as a state register. It handles validation states, which is an enum, however you want to pronounce it. That's set here. So if the user hasn't entered an address, I don't want to yell at them about that yet. If I'm checking the address because I've detected an event of any kind, then I want that little spinner to say, hey, I'm checking your address. I'm doing something. I've recognized that. Invalid, in the case I throw an address that is just worthless, then I want to be able to show a message, so I'm going to put myself in an invalid state. Suggesting is when I'm showing those cards. That's neither valid nor invalid. That's some other state, so suggesting. And then lastly, valid tells me that I have selected an address that came back from my address validation service. So this behavior subject has a cache that is of the shape validation state. Only validation states can go into it. Only validation states can come out of it. So it's a handy little state register. If we look further down, we have state management going on in these various handler suggestions, handler functions.
You're going to show the state definitions as well at some point?
The state definitions, that's it right there. Validation state, that's it.
But what's the rule? How do you transition from one?
Oh, how do we transition from one to the other? Sure, yeah. So we initialize to idle. So that's our starting case. Let's see. Handle address change. This happens every time value changes gets fired. So every time there's a key down, a key press, any kind of character change in the whole of the address form, this subscription fires. So if we look at handle address change, it dumps into our state either idle or checking based on if the address is empty. Because if the user clears all the data out of the address, I want to return to idle. I don't want to yell at them about that. But if they're typing something, I'm going to tell them we're checking. So that's how we get into checking. When we get an address or set of addresses back, this subscription handles hitting the validation service. So we're talking to a service and saying, hey, go check this address. It's kind of a black box. It goes off into nowhere. But this subscription grabs the validation results that come back into the behavior subject that's in the service. And if we want to look at the service, it's a pretty simple little guy. So we have a behavior subject, which is our cache. It's the shape of an array of addresses. I can get back more than one, as we saw in the demo. Check address takes the address, checks if it's empty. If it is, we just shove null and say, hey, you didn't give me anything to work with. So whoever's listening and whoever asked for addresses is going to get a next, so a success, of empty. However, if we did get an address to check, then we throw it at Smarty Streets. And we either, I won't bore you with parse results because Smarty Streets sends back this big, massive, ugly thing with latitude and longitude coordinates of the address. It's crazy. We parse the results very nicely into our address object and pass it into the validation results. If we get nothing from Smarty Streets, throws an error, then we throw an error onto our behavior subjects that the address was invalid. So that's the service. Back here, our subscription. If we get success, we just handle success, which clears the errors and sets the state to suggesting. Hey, addresses came back. Cool. It's up to the user to pick them. Our suggestions child is going to worry about displaying them, separation of concerns. It's bothered with showing those and doing something with them. And then it's just going to hang out until eventually the user goes back and types, which fires off that handle address change and sets us back into checking. Or if the user selects something, then our child emits the event of the address that was chosen, which comes into the set address function, and we set the state to valid. So that's basically the state flow. It's kind of a logical order as described. We're idle or we're checking based on what the user gave us. We're either invalid or suggesting. If we get to suggesting and they pick something, it's valid. If they start typing, we go back to checking. So that's the state machine. I don't have it documented very well here, but I can add something to the README of the project that explains a little bit more about how it works.
So it's the document of the subject, the behavior subject. Say you can use it as a state machine. Is that the state machine keyword in the document of the RxJS?
No, the RxJS just says here's a behavior subject. It does these couple things. Use it for whatever you want. I'm using it as a state register because I think that's a pretty useful way to use it. It's just one of the ways you can do it. It's a tool in your toolbox.
I think state register is probably a more like accurate way to call it, because if you say state machine, one thing about state machine, you have state, right? The rule of all this state transition will also be defined as part of the state machine.
Sure.
And then when you use that state machine, you actually you don't transit the state to state. You say you fire event to it. So the state machine is in state 1. With event 1, it will go to state 2 or 3, and then you just keep going around with that.
Right.
And that's where you can even like draw a state machine, see how it goes. That's how you can prevent all this errors. But I think in this use case, you have a state register, and you have your own rules pushing your current state into it. It's kind of like a register. You can keep changing what's current state, but there's no like protection around the flow control of your state of this.
Yeah, yeah, and that's why this example doesn't adhere to anything like. It's like what is it? It's more.
I think that's a very useful way to control your whole flow.
Yeah, and if we notice, it's marked as an output, so anybody who wants to can listen to it and listen to the state, which is useful for the parent component, which handles the entire form. And it's the parent component that displays the error messages and things that might be a result of whatever that state happens to be.
So when you use the output, is it better to expose it as an observable or behavior subject?
It depends on your purpose. If you don't want whatever is outside to be able to change the state, then you would probably want to have it output as an observable so that you've protected the input and the ability to change the state. I didn't consider that, mostly because this project was built in a couple hours. So there's going to be holes and things that break about it. I'm just happy all of the tests pass. So yeah, you could output it. You could also, You could instead output a subject and have the subject subscribe to the behavior subject. So that way you can just expose the whole thing and not have to worry about casting it as an observable, because nobody can stuff a new state into the subject. Well, they can, but it's not going to actually change your real state. But yeah, that goes back to the scope consideration. You know, do we expose things? Do we not expose things? Is that safe? Is that not safe? I mean, hopefully all of this stuff is within our own code base, so we can be smart enough to prevent those kind of problems. But as several years of testing experience have told me, there's always a smarter tester, to put it politely.
Did I get it correctly? So you have address API,
Mm-hmm.
and you trigger it through the changing the state.
Mm-hmm.
And as an I understood, like HTTP client will close itself once it's fetched. It completes that call.
Mm-hmm.
So you need to trigger again and again.
Mm-hmm. And that's why the check address function handles the HTTP client call, and then when that completes, this parse results function, which goes through the list of results and converts it into an address. At the very end, it stuffs those addresses into the behavior subject, which is the cache inside the service. So basically, it's kind of like ordering something online, right? I talk to one thing, but something else comes and gives me the stuff. In a way. So the way that this works, and I don't think I strongly typed it, but realistically this could be typed void, so you know for 100% sure that this is not going to return the thing that you're looking for. Instead, you have to go get it from the cache. So the nice thing here is that, and which if we go look at the list page, is exactly how this is used. One thing controls it, other things can listen to it. So that's a great segue. Let's go, don't save. Let's go take a look at that list, a set of list stuff. So the parent list, no, info collection, that's not what I'm looking for. Here we go. So the parent list HTML is pretty simple. It has the header. It has an ng-if about showing the cards, switched with errors and question marks. But most importantly, it pulls in a set of list controls, which are those 4 toggles at the top. And then it has in a for loop a set of these list cards, which pass in the individual employee object from the loop. So that's how each card knows what data to display. If we look at the list controls, we see a whole bunch of selects as those 4 controls are built. In the TypeScript for this, we have an update page which fires first in the ng and init. That primes the page with the initial data. We subscribe to the current page in the service. So again, I have a behavior subject in a service. That's the current page. We subscribe to it so that we know how many pages there are. That's what lets us set the 1 of 2, 2 of 2, 3 of 4 in that one control. And then, just like before, we're listening to value changes on all 4 controls because we're listening to the parent level form, not the individual pieces. And anytime the settings change, we call that same update page function. And that update page function just takes those settings from our little form, preps them into a set of settings that are consumable by the service, and the service get page function takes those and throws them against a, it's a JPA repository, so it inherits paging and sorting from the lower level things. But it builds our page requests. What's the sort field we're sorting on? How many items per page? What page do we want? All that kind of stuff. And when we get the results, we again convert it from JSON into our object, and we dump it into the current page. So that controls component catches any change to the 4 controls and goes and kicks the service and says, hey, give me this page. And the service goes and gets it, stuffs it into the register, and the list display, so if we head back to the list component, this guy's really rather simple. The main thing we're doing here is listening to the current page on a subject. Whenever we get an updated page, we store it. Handle new page. If we get an error, we throw an error. It's literally all this guy does. Just watches for new pages and displays them. Handle new page clears errors and sets the current page to whatever we got. Handle error sets the error to whatever we get and sets the current page to an empty. That's all it's doing. But this is a pretty nicely decoupling, pretty good decouple of separation of concerns. One thing is responsible for configuration of the page that's being viewed and going and getting it. The service does the work of firing the HTTP call and storing it into that cache. And then this guy is just responsible for responding to changes wherever they should happen to come from. If I build a second set of controls, or if I mirror the controls at the top and the bottom of the list, so I have that same child in there twice, it doesn't matter which child sends the event. I don't have to try to listen to both and try to figure out which one's page do I listen to. Instead, everybody just communicates with that service. The controls push a change event, and the service goes and gets the page, and the list can then adjust as needed. Bonus points if anybody finds something interesting with all of these people.
Blue Raptor earlier.
That's an interesting one.
That was fun.
T-Rex.
Room one.
Yeah, there it is. These are all Jurassic. It's the Jurassic Park convention. So again, for whatever reason, ascending and descending isn't working. I don't know why. But you guys have the code repos now. You guys figure it out.
Is it calling a Spring application?
Yeah,
Oh, okay.
yeah, it is. And if we look at the call, this adheres to the JPA convention, and I get a page back, so it's not yelling about any of my configurations. But for whatever reason, ascending or descending doesn't seem to be working. So not sure what's going on there, but yeah, it's interesting stuff. I do have an example in here of just a plain old subject, and that goes back to address validation. Just to complete the circle. So in my address suggestions, my address suggestion card, so this pops up those 2 or 3 corrected addresses. When you click that select button, the handler for that event, or the observer on that observable event, is the address selected.next. And whenever we see .next, we know we're talking to a subject. So who is that talking to? Well, the suggestions component has a subject that is output of type address. So when we hit the select button, straight from the HTML, we're taking the address object and dumping it into the subject. So anybody listening to this can grab and know what address was selected. And if we look at the parent has a function for handling when one of the addresses is selected. So this is an example of how we listen to an event that's outside the scope of what we're trying to do. So diving down into the HTML of the child would be rather difficult to try to tie into that click event. I could do something with an event emitter, maybe, but I'm fairly well convinced that an event emitter is just a subject under the hood anyway, because they both use a single function. They just call it emit instead of next, and they fire events. But. So, subjects, behavior subjects. There's some async subjects in here, but they're not very prevalent. I'm pretty sure that ShareReplay is, well, I know ShareReplay is a replay subject, and I'm also fairly convinced that debounce time and debounce are replay subjects under the hood. So check those out. Any other questions?
Maybe very silly one.
Please.
So instead of doing this cache business, it's like we just, and I understand that you can control the scope, but if it has to be broadcasted to anything, what is the problem with the local storage or something like that?
So one case where local storage doesn't help you very well is if it's disabled on the machine. I have done a lot of government work on most government machines. Local storage is no cookies, no nothing.
Actually, no matter when you do it, like they always say local storage is not a great idea. There is like other things you can use instead of.
I think you could use local storage for a couple things. If you were dealing with, say, a list of countries or a list of states, you could dump that into local storage, and maybe that expires every week, and you go get a new copy of it. But the other problem with local storage is you're passing control outside of your control. You're talking to the browser, it's going to go at browser speed, which is never fast enough. What happens if something else overwrites that file? What happens if that file gets corrupted? You can use local storage as effectively a database, but I think you're going to run into all kinds of problems if you do that.
There is some closer to that cache storage or something. That is also not allowed. No.
I'm not familiar with that. I'm not sure.
But other than that, in terms of functionality, if it is allowed, suppose it's allowed, then what other things we gain going through this? Of course, we gain lots of things. I'm just trying to put my
The main reason I would suggest using subjects is, and this is speaking as somebody who hasn't used local cache, used some of those other things. Subjects and observables, subscriptions, those are all things that have been baked into Angular. These are things that Angular does very, very well. You get them for free effectively. So if you can stay within the realm of what Angular knows and does really well, then you're going to see performance benefits. You're not going to have to deal with potentially third-party APIs. If I'm dealing with local cache, for instance, how does that function in IE versus Firefox versus Safari versus Opera versus all these other browsers? Do I have to worry about all that compatibility stuff? The behavior subjects, the downside is they're volatile, right? If they close the page and open the page, it's gone, right? You're not saving it anywhere. So that is a benefit to something like local storage, where it's going to be there when you come back, assuming the user hasn't cleared their data, of course. But that's the best answer I got for you.
Is there a way to write test cases to make sure that the unsubscription is happening correctly?
Yeah. Let's write a test real quick. So one of the things you could do. That's a good question. I haven't done that before. Let's see if we can figure it out. So if we grab a component that has a bunch of subscriptions, that's going to be something like this, where we've got 3 of them. So my ng on destroy runs through my array of subscriptions, and for each of them unsubscribes. So what I might be able to do is let's see. What I can probably do is I can probably spy on well, I can't grab one of the subjects, and on this file the list of subjects is private, so I'll have to expose it before I can do that.
So in Java, the spies you can get a handle on the private variables, right?
Yeah, I have found with Angular, if it's not even protected, can have a problem with the testbed. It's got to be public. So I can do spy on property. So now I can spy on a property, and then if I call component.ng on destroy, if I call that manually, I might be able to check the length of my subscriptions to see if they got closed. I'm not sure. It's a good question. Let's see what happens. It's a good question. Nope, that's not going to work.
I don't think the unsubscribe is removing it from your list.
Pardon?
I don't think the unsubscribe call will remove them from the subscriptions.
Probably not.
Orange.
There we go. Maybe I can check to see if the first item in the thing has been closed. Nope. So I think this would work if I had subscriptions, the property set up correctly. For whatever reason, it doesn't seem to like spy on property. Yeah, I think I would need to expose this as give an engineer a problem, right?
Those got the same thing.
Maybe, we'll see. I don't know if it ran or not, or yeah, still doesn't like something. I'm sure there's a way to do it. I have not done it before. So cannot read property 0 of undefined. It doesn't like it. Sorry.
I mean, would it show up on the Google console if there's a leak in a fairly large application?
Right, and if you're doing a lot of stuff with Angular, you should definitely check out the. Oh Lord, just stop. Cool. Have you checked out the Augury Chrome extension?
Yeah, but it's not allowed.
Oh yeah, that's yeah.
Government.
Yeah. Thank you, DC Tech Corridor, for sure. Yeah, what you could do is you could do an audit of your components and make sure that all of your subscriptions are being unsubscribed and put your faith in Angular that it's doing what it needs to. I would expect that if it didn't, there'd be enough other people crying about having it fixed that should help you. But
yeah, I'm just worried the developers themselves forget to unsubscribe and destroy it.
Yeah.
And then it's a fairly large application.
Okay. Yeah, do you have any thoughts on?
I mean, if you're worried about, actually, no, I mean, no. As far as checking that, I wonder if you could do something along the lines of interfaces and then make everything implement something that has to have on. No, but still, that's just making that doesn't force them to do on destroy. That just forces them to have on destroy.
Yeah.
I mean, we do a lot of code review and all that.
Yeah,
Try
I
to
mean,
catch the
Yeah. Well, the good thing is when the user closes the tab, it all gets thrown away by the browser anyway. So, yeah, just rely on that garbage collection. We've got 8 more minutes per the schedule. Anybody have any other questions or thoughts, concerns, righteous indignation?
Can you talk about Augury?
Talk about Augury. I haven't used it a ton. The prettiest part of it is the router tree because it makes pretty graphs. If you have a more complex thing than this, it'll show you things that are lazy loaded. It'll show you, and it'll do it live too. So when you hit one of those lazily loaded modules, then it pops up a new thing and shows you that kind of cool stuff. ng modules shows you all the different stuff that's currently running. And the other cool thing is it nicely shows you where different things are on the page. So if you're not quite sure all those different things, it kind of nicely shows you where all those components and things might happen to be. But it doesn't show you everything. Like these are just divs as far as it's concerned. But I can dive into the list controls component here, and I can see all of the details about, well, my sort by array has objects, and they have values, and they have names, and I can dive into all this kind of stuff. So it's useful for debugging and kind of seeing the application just kind of in a state. If you're going to do any kind of breakpoint, then your sources tab is far and away the better thing. I wish this dove into the source code a little bit better and not have to dig through a whole bunch of folders to get to it. But nevertheless, we dig down through, we see our fairly familiar folder structure to what we've got here. And sure enough, as long as we're not running in production mode, as long as we're running in dev mode, then we can dive into the sources and we can throw breakpoints on things. I find this to be the pain I'm using a lot more often than Augury, but especially if you're doing what Dohan preaches and doing a router first kind of a thing where you're just making empty components and wiring them up with routers, then Augury is really helpful to know if your router trees are working the way you think they are or should be, or if you end up with back buttons that don't work or router navigations that don't go where you think they do, then Augury can be helpful. But I think it's really meant to just augment the other tools in your stuff. I don't think it's the catch-all for debugging. Yeah?
Do you have an example of ReplaySubject?
I don't. I don't in here. But I know if we go, if we go and look at ShareReplay, if we go look at the source code, let's see here. I'm not going to believe this GitHub link, but let's give it a shot anyway. Yeah, it's just going to take me off to the docs. There we go. Let's see here. I can search in this repo, right? I'm pretty sure ShareReplay. Let's see here. Yeah, that's, I think, an interface. I know for a fact that ShareReplay just wraps a ReplaySubject. I don't know if I can find proof of it in a timely manner, but I know it's there. I mean, if you use a ReplaySubject, you set the buffer to size 1 and don't give a timeout, it's basically a BehaviorSubject, except you can't access the data synchronously.
You mentioned ShareReplay a lot. Like, what do you use?
Okay. So ShareReplay is cool. If you attach that to, if you throw that in a pipe and you throw it after the end of a API call, then what ends up happening is any new subscribers that attempt to go grab that, I don't think I have it in here, but basically if we were to throw in here, something like that, it's going to yell at me about not having it imported. But and instead of doing the subscribe here, if I just exposed the pipe as the observable to like a function that wraps a Git call, then basically anytime you go hit that function again and say, hey, give me that list of states, hey, give me the list of states, give me the list of states, it instead hits the ShareReplay and just gets what you've already gotten instead of hammering the back end every single time. So it's a really cheap way to just say, I only expect to need to call this once because it's data that's not changing very often. List of states, list of countries, list of other things that never ever changes. Option lists are great for it. If you have controls that have a set of options, like I could wrap all of these 4 things in a list of, I could dump these options into a database, right? I don't need to get them once. I don't need to get it every time the user toggles between 2 components because they're loaded already. I don't need to go hammer the API off all the time. So ShareReplay will protect you from that. And then you don't have to write a whole bunch of, you don't have to build a cache. You don't have to build any of that other kind of stuff. It's just going to say, yeah, we already got it here, take it. So it's pretty nice. And I do believe that a debounce time is, again, just a replay subject size 1, and it takes whatever expiration time you've set.